Let's dive into a concept that really unlocks the power of abstraction and polymorphism in Rust. That's right, we're talking about traits. So what are traits? In simple terms, traits in Rust are like interfaces in other languages. They define shared behavior. If a type implements a trait, it means it guarantees it can perform that behavior. And that's a big deal when you want your code to be flexible, reusable, and still super safe. Let's build from the ground up with some examples. Let's say we want to model behavior for different animals that can make sounds. We can start by creating a trait called speak. The speak trait defines a common behavior, speak, that any type can implement. It has one method, speak, which doesn't return anything, just prints a sound. There's no default implementation for now. We'll add one later. All right, now let's define a couple of structs. Both the dog and cat structs have their own unique data, a name. Now, to give them behavior, we implement the speak trait for each of them. We've now taught our dog and cat how to speak. The speak trait provides both the dog and cat structs, their specific version of the speak method. We've now taught our dog how to speak in their own way. If you are not familiar with the implementation block, please check out previous videos of the series. Let's try using them. In the main function, instances of dog and cat are created, and the speak method is called on each. Although the method call looks the same, dog.speak and cat.speak, the specific implementation that is executed depends on the type of the object, resulting in different outputs. Rex says, woof, and Sassy says, meow. Simple, right? We've abstracted behavior across multiple structs using the same trait. Now the cool thing is we can write functions that work with anything that implements speak. This example demonstrates polymorphism through traits. This is a core concept of object-oriented programming, allowing for flexible and reusable code. Let's make a function that takes any animal and makes it speak. The generic function makeItSpeak takes any type T that implements the speak trait. This function doesn't need to know if it's a dog or a cat. It just knows that whatever it receives can speak. Now you can use it like this. In the main function, instances of dog and cat are passed to make it speak, demonstrating how the same function can work with different types, as long as they conform to the speak trait. This approach allows for highly flexible and reusable code, as the makeItSpeak function can be used with any future type that also implements the speak trait. This is generic programming with trait bounds, a super powerful Rust feature. But there's another way to write that function using implement trait. Now, the function makeItSpeak uses the implementSpeak syntax in its parameter, which is syntactic sugar for a generic function. This means the function accepts any type that implements the speak trait, without needing to explicitly define a generic type parameter like a generic type T that implements speak. Both styles work great. Implement trait is often more concise and easier to read. Let's say now each animal should not only speak, but return its sound as a string. We'll tweak the trait a bit. The speak trait now specifies a method speak that returns a string. We have to update the implementations as well. The speak function will now return a string instead of printing a statement. The dog's implementation returns woof, while the cat's returns meow. And in your main, the speak method is then called on each instance, and its return value is printed in the console. This showcases how the same method call can produce different results depending on the type of the object, effectively demonstrating dynamic dispatch at compile time. This Rust code demonstrates polymorphism using a trait to define a common interface for different types. What if we want a default way of speaking, but allow types to override it? You can totally do that. We can add a method to the trait with a default implementation. The speak trait defines a speak method, but instead of just a signature, it provides a default body that prints the animal makes a sound. If we now define a new struct called bird, we can use the default implementation without having to write our own. The bird struct implements the speak trait, but it doesn't provide its own implementation of the speak method. Because the trait provides a default implementation, the compiler automatically uses that implementation. In the main function, an instance of bird is created, and the speak method is called. This demonstrates how a trait can provide a fallback behavior, allowing types to opt into that behavior without having to write any code, making it convenient for common cases, while still allowing for custom implementations when needed. So, we just saw how traits can offer default implementations. What if we wanted to add another characteristic, like friendliness of the bird? Let's say most birds are friendly. To add this characteristic, we are adding a function isFriendly, which defaults to returning true. Now, if we don't override is friendly in the implement's block, it will return true by default. The bird struct implements speak, but doesn't override any methods, thus inheriting both the default speak and is friendly behaviors. But if one bird isn't so friendly, we can customize it. Let's add another bird, duck. Also, implement speak, but it only overrides the isFriendly method to return false, relying on the default implementation for speak. In main, we call the isFriendly function on both struct, bird and duck. We will get the output, true for the bird as it is using the default implementation of isFriendly, and false for the duck as it overrides the default implementation of isFriendly. Default methods help you avoid repeating yourself when most types share the same behavior, but you still keep the option to override default trait methods when needed. Traits are one of the reasons Rust can have polymorphism without inheritance. Instead of saying cat inherits from animal, you say cat implements speak. You get all the flexibility, but none of the mess, because everything is explicit and type-checked at compile time. What if we have multiple traits? Here we have introduced another trait, run. The run trait, providing a run method, which doesn't return anything, just prints a running message. The dog struct implements both the speak and run trait. Now a dog can speak and run. And that's trait composition. Extremely handy. In main, individual trait methods are called onDogInstance, effectively showcasing how Rust's trait system enables types to have multiple capabilities and how functions can require these composite capabilities. This Rust code demonstrates how a single type can implement multiple traits and how generic functions can enforce multiple trait bounds. Now let's look at enums. Traits work beautifully with them too. Say we have an enum to represent payment methods. The payment method enum represents different payment types, each holding associated data. We want each payment method to print how it's being processed. Let's define a trait, processPayment. The processPayment trait defines a process method. And now we implement it for our enum. We are using a match statement to perform different actions based on which payment method variant is being processed. This kind of trait implementation over an enum is super powerful. It lets you define different logic per variant, neatly and cleanly. And we use it like this. In main, instances of each payment method variant are created, and the process method is called on them. This showcases how the same method call, process, behaves differently depending on the specific enum variant, providing a clear and type-safe way to handle distinct but related operations within a single conceptual entity. This Rust code demonstrates how an enum can implement a trait to provide polymorphic behavior based on its variants. Now you might ask, what if I want to store different types that implement speak in a single collection? You can do this using trait objects. In the main function, a vector named animals is created to hold a box of dynamic speak. Box of dynamic speak is a trait object, which allows a collection to store values of different concrete types, like dog and cat, as long as they implement the speak trait by putting them on the heap. This allows the program to treat them polymorphically. The for loop then iterates through this vector, calling speak on each animal. At runtime, Rust determines the concrete type of each boxed animal and calls the appropriate speak implementation, either dogs or cats, showcasing dynamic dispatch. This is Rust's version of dynamic dispatch, and it's type-safe. Traits allow us to define shared behavior across types without needing inheritance. They give you flexibility with safety, and they form the foundation of generics, interfaces, and zero-cost abstractions in Rust.